and welcome to this lesson on finding the missing sides of a right-angled triangle using trigonometry. Now, before we start, make sure that your calculator is set in degree mode, as we will be working with degrees today. And if it's not set in degree mode, on a standard Casio calculator, the way to change it to degree mode is Shift, Setup, and then you'll have an options menu and you want to click degree, which is usually just DEG. For me, it's number 3 in that menu. And you know it's in degree mode if there is a little D on the bar at the top. Okay, so let's get into it. In our first example, we're asked to find the missing side, X. The first thing that we want to do in these types of questions is to label the sides of our triangle. So we know that this side here, which is 5 centimeters, is the hypotenuse. It's a longer side and it's a side that's opposite the right angle. We know that this side here, which is represented by X centimeters, is called the opposite side, as it's opposite the angle in question. And the remaining side is just the adjacent side. It is a side that is next to the angle we are considering that has not been labelled. Now that we have labelled the sides of this triangle, we want to figure out which sides will be relevant to us in this question. Well, obviously, this side here, the opposite side, will be relevant to us because we want to find the length of this side. And we have that the hypotenuse is 5 centimeters long. So we have a measurement for the length of the side of the hypotenuse. So this side will also be relevant. We have no information on the adjacent side. We don't know how long it is, and we're not asked to find anything about it. So in this question, the adjacent side is irrelevant. So what we do now is we look at our 3 trigonometric ratios. We can recall these trigonometric ratios from SOHCAHTOA or using a different method. We look which of these trigonometric ratios involve using the adjacent side and we cross them out as we will not be needing them. So if we look at the tangent trigonometric ratio, it contains the adjacent side, so we cross this ratio out, we will not be using it. If you look at the cosine trigonometric ratio, it contains the adjacent side, so we also cross this ratio out, we will not be using it. And we have one ratio left, which is the sine ratio, which does not contain the adjacent side. So this is a trigonometric ratio we will be using in this question. All we need to do now is substitute in our known information. So we have sine of 35 from our 35 degrees here, because our angle is just represented by theta, is equals to, well, our opposite side is just X centimeters, and our hypotenuse is 5 centimeters. So all we need to do now is rearrange this equation to find X, and we have our answer. That would be the length of the opposite side. So what we need to do here is times each side of this equation by 5. And in doing this, we get 5 times sine of 35 on the left-hand side, and on the right-hand side, we just get X. So we have solved for X, and if we punch this into our calculator, being careful about our brackets, making sure to close the brackets around the 35, we get that X is equals to 2.87. So just like that, all we needed to do was select the correct trigonometric ratio, substitute in our known knowledge, and then rearrange, and we've got an answer for the length of the opposite side of the triangle, which is 2.87, and that is to 2 decimal places. In our next question, we're asked to find x, the length of this missing side. So again, our first step is to label the sides of this triangle. We have that the hypotenuse is here. It's the longest side of the triangle, and it's a side that is opposite the right angle. We have that the opposite side is here. It's a side that is opposite the angle in question. And the remaining side is the adjacent side. It's a side that is next to the angle in question, which hasn't already been labelled. So now we need to decide what sides of this triangle are relevant to us. Well, the hypotenuse is relevant to us because we need to find the length of it for our question. The adjacent side is relevant for us because we have a measurement for how long this adjacent side is. The opposite side is not relevant to us because we have no measurement of how long this side is, and we are not asked to find it. So what we need to do yet again is go to our trigonometric ratios and look at all of the ratios which involve the opposite side, and we want to get rid of these ratios. So the sine trigonometric ratio contains the opposite side, so we get rid of that. And the tangent trigonometric ratio contains the opposite side, so we get rid of that. And we left with the cos trigonometric ratio, which does not involve the opposite side. So all that we need to do now is substitute in the information that we know. So cos of 50, again 50 has come from this angle, which is just represented by theta, is equals to the adjacent, which is here 3.1, divided by the hypotenuse, which is just x, and this is the x that we are trying to find in this question. So all we need to do now is rearrange this equation for x. We can do this in two steps. Firstly, we multiply both sides of this equation by x. So if we do that, on the left-hand side, we'll get x multiplied by cos 50, and on the right-hand side, we'll just get 3.1. Now, the second thing we need to do in this rearrangement to get x on its own is just to divide both sides by cos 50. And in doing this, on the left-hand side, we will just get x, and on the right-hand side, we will get 3.1 divided by cos of 50. And all we have done here to get from this line to this line is just rearrange for this x. That's all we're trying to do. And now, all we need to do is punch this into a calculator, 3.1 divided by cos 50, and make sure, again, you have the brackets around the 50. Be very careful of how you use your brackets in your calculator when you're dealing with these trigonometric functions. And if you type that into calculator, you will get that x is equals to 4.82, and that is to 2 decimal places. So just like that, we found the length of the hypotenuse, the side that we wanted to find, from using a trigonometric ratio and rearranging our formula. In our final example, we're asked again to find the missing side x. So, as usual, we need to label the sides of this triangle. We have the hypotenuse as a longest side, which is also opposite the right angle. We have the opposite side over here, the side which is opposite the angle in question. And we have the adjacent side here, the final side, which is next to the angle in question, and the side that is not already labelled. So again, we need to decide which sides of this triangle are relevant to us. Well, the opposite side is relevant because we want to find out the length of this side for the question. The adjacent side is relevant because we have a length of this side. The hypotenuse side is not relevant. We do not have any measurements for how long this side is, and we are not asked to define the length of this side. So in this triangle, we say the hypotenuse side is not relevant to us. So what we need to do now is look at our trigonometric ratios and cross out any ratios which involve the hypotenuse. The sine trigonometric ratio contains a hypotenuse, so we bin that. The cos trigonometric ratio contains a hypotenuse, so we also bin that. We're left with a tangent trigonometric ratio which does not contain the hypotenuse side. So all we need to do now is substitute in the information that we know and rearrange for x. So doing this, we have that tan of 30. We get 30 from the angle that we know, which is just represented by theta, is equals to the opposite. Well, here, the opposite is just x, and that is divided by the adjacent, and here, the adjacent is just 9 centimeters. So all we need to do now is rearrange this equation for x, and that will be the length of our side. So to do this, we just need to times both sides of this equation by 9. And in doing this, on the left-hand side, we get 9 times tan 30 is equals to x. And if we just punch this into our calculator, again being careful about our brackets, we get that x is equals to 5.20, and that is to 2 decimal places. So we have just found out that the length of this side here is 5.2 centimeters, and we have done that from using a trigonometric ratio that we have picked, and then just rearranging after substituting in the relevant information to find the length of that side. If you have any questions, leave a comment below or shoot me an email. Thank you for watching.